Bill Pettit is the Director of Maintenance and Engineering for Purdue Agribusiness in Salisbury, Maryland, a position he's held for 18 months. Previously, Bill was Director of Engineering for Magnet Cedar Refractories for 5 years and served in a variety of engineering capacities for the 10 years that he was associated also with Voith Turbo. With those companies, he designed and constructed projects for steel and coal industry, including the supervision of a plant built in China. Bill holds a mechanical engineering degree from Messiah College and a master's degree in systems engineering from Johns Hopkins University. In his capacity at Purdue Agribusiness, he's responsible for the engineering, maintenance, and purchasing, as well as initiation of large-scale project management. It is his task to take someone else's idea through evaluation and implementation stages through full fruition for the company. Bill's here today to talk about new concepts in project design, including project scope and getting the collective buy-in from stakeholders. If you would, welcome Bill Pettit.
Thank you, Greg. Thank you for inviting me to this, this time together. A couple things you should know about me. First of all, I like to walk around when I talk, so that hopefully keeps everybody engaged, nobody falls asleep. If you do fall asleep, I'll ask a question to you. The other thing you should know about me is this little clock here right now is set for the total time, and nobody started it, so I've still got 90 minutes. And the last thing you should know about me, and this is the most important, it is it's always important to put the short round guy right in front of lunch. So you know we will not go 90 minutes past right now. The topic today, project scope, definition, development, and management. I'm hitting a button. I'm hitting another button. There we go. What are we going to talk about? We're going to have a little introduction. We're going to talk about scope. Why is it important that we sit here and talk about scope? Why is this a big deal? Why is this guy standing in front of you chatting? We need to talk about the process. It is an iterative process, meaning we go around a couple times. And if you haven't gone around a couple times on your projects, you haven't fully vetted the challenges that those projects face. What tools are at our disposal? There's a lot of technical tools, but there's some pretty basic fundamental tools that we need to utilize in the industry and we need to utilize as we're developing projects. When this was presented to me, hey, could you do a little talk on this? I asked who the audience is. I thought, well, if it's a bunch of engineers, great, we'll chat about whatever. Well, it's engineers, it's operators, it's maintenance guys, it's CEOs, it's executives. As a broad group to try to take this all to. So when we talk about the tools, I want to talk about what does it look like as we're going down the road, what basic questions need to be asked if you're in the higher tier to make sure that your associates are vetting the projects. If you're not the CFO or the CEO, what can you utilize to make sure that we're not putting in the supplemental request for additional dollars at the end of the project because we forgot something. We're going to talk about some brief applications, and we're going to talk just how does this apply, and a couple examples out of my own career, and we've all got war stories. We've all been down the project road of projects that didn't work out well, and I just share a couple of my own. So if we talk about basics, why are we here? Let's talk about baseball for a second. I was stunned when I kind of read this and I saw it. I thought that's kind of interesting. Of every 7,000 kids, 7,500 kids that play Little League, and there's over 2 million Little League baseball players, this doesn't include softball. 2 million kids play every year. Of 7,500 of them, 1,700 will go on to play for their local high school. The 1,700 that play for high school, 95 will play in college. 10 of those will play in the minors, and 1 out of those 10 will play 1 inning in 1 Major League Baseball game. That is an awesome stat. To play 1 inning in 1 Major League Baseball game, you are the best of 7,559 kids that ever played Little League. That's a pretty big drop. It's 0.013% for those of you that like to talk about percents. What does that have to do with scope and scope development? Well, if any of you have ever walked, I'm a New York Yankees fan, so you can all cheer with me right now, yay. Well, what happened? Come on. You were with me, you're not with me anymore. That is so hurtful. When I was a kid, I can remember walking out with my dad. We got tickets to a Yankee game. I can even tell you who they were playing. They were playing the Royals, I believe. My dad got tickets from an insurance company. We went and saw a baseball game. We sat 8 seats over from home plate and 2 rows off the field. We got there before the game started. I saw Dave Winfield take batting practice. It's back in the day a little bit. But the thing that struck me at that point, because I was playing Little League, was these guys, when they're practicing before the game, you know, it's not Jeter going backside into the hole and throwing in the air to first base. They throw the ball, they hit the ball to them, they drop down, they put their glove on the ground, they pick it up, and they throw it to first. There's nothing fancy about pregame warm-up. Every game starts with Major League Baseball players warming up, doing little more than the same drills that they learned as kids when they were playing Little League. My daughter plays Little League. It is a trip to watch, but the same drills, the same, we're going to roll the ball to you, you square your shoulders, you put your glove down, between your legs, it's the basics. And we have to go back to the basics sometimes to remind ourselves, what are we doing? How many times do we sit, somebody comes into your office and they go, hey, I got a great idea. I want to go build a plant. Hey, I got a great idea. I'm going to put 1 million bushels of storage in somewhere. And we suddenly run down the path, and as Bill shared before, we start picking vendors, we start picking everything, and we don't go back to the basics. We don't put our glove on the ground and do some of the basic concept development, engineering development, and just some of the basic standards of the process. From the purely academic standpoint, these are the 3 main, every project has these 3 steps. We tend to skip steps. I know in my own department, on occasion, we might skip a step. We might just start placing purchase orders. It's happened. I'm not going to deny it. But generally speaking, if we're doing it by the book, we have a concept, we have an operational deficiency, we have a technical opportunity, we sit down as a group, we pull through that, we look at what are the functional, what do I need to accomplish, here's a deficiency I need to correct, here's how I'm going to functionally do that. Out of that, we develop production specs, we develop requirements for the equipment that we're going to purchase. Out of that, we buy it, we build it, we run it, we turn into an operation and a maintenance process at that point. I will say this also, most of my career has been tied less to project development and more to maintenance, which means, and at one point I ran a field service group, I have fixed more problems from people who forgot to design it right, which is why I get fairly passionate about some of this, because once it's in the field, it's going to cost a whole lot more, and everybody in this room knows that, and you have people shaking their heads all around, which is great. But we have to just remember, we have to take a moment of pause and think about the process. So if we break these down, the concept development, what does that look like? We confirm a valid need for a system, which is technically and economically feasible. We'll get a little bit into later the difference between needs and wants. Anybody here have kids? Raise your hands if you have kids. I have quite a crew. Daddy, I need a new app for my iPad. Daddy, I need a new video game. Daddy, God bless my parents. I heard a number of times as a child, you need 3 things. Anybody want to call them out? Food, water, shelter. Pretty much everything else, you want it. That's not this, don't ever go to my parents and say, we're wonderful people, and yada, yada, yada. But when we sit down, when we're developing a process, we're talking about real money. We're talking about real expense. And that real expense needs to be tied to a valid need. And if we start with what's the need and we write it down, it helps set everything else. It helps set the standard as we go forward. So it's not turning into oh, I want a little of this and I want a little of that. And then what's the biggest problem on projects? A lot of people talk about it, scope creep. I started building a 1,000,000 bushel bin. I've now designed 3 million bushels of storage, some flat storage, and it's just gone crazy. We need to explore concepts after we determine the need. We explore the concepts and develop a set of system performance requirements. We define the need and we define the basic requirements to satisfy the need. As we're doing this, what happens? A lot of the other wants fall by the wayside. That doesn't mean that they disappear and we don't ever bring them back. But we define things and we bring that scope down to something that is truly manageable. And finally, we select a system concept and define functional characteristics, and we plan the next stages. Well, if you're selecting a system concept, that means that there's probably more than one system concept, which is the first kind of overarching piece that I want to bring to the table. If you go into a project and you've only got one idea on how to get the project done, you need to send whomever back to the table and come up with another idea. Even if it's a crazy, doesn't make sense idea, because you have to challenge yourself to make sure that you vetted it. I'll give an example. We were approached, my team was approached, one of our facilities, they wanted to expand their shipping capability. Okay, so we reached out to some people. It was a little bit beyond the scope of what my team of engineers were going to do. We reached out to an engineering firm. We brought them in. We said, hey, we want to develop this. This is what we'd like to do. They went full bore down the road. We had the need. We explored the concept. We explored a concept. We got it done. We looked at the price and we went, holy moly, this is not going to happen. And we went back through and we started picking apart everything that was there, and we came up with the same price. And we thought, this is not going to happen. And then somebody got the idea in my department. They said, well, what about, we talked to this group, what if we talk to this group? We said, well, yeah, but we know this is how we want to do it. This is the best way to do it. Brought the second group in, cut the price in half, because they looked at it a different way, and they said, well, you don't need to go there, you can go here. You don't need to do this, you can do this. This we would do the same. And it's that concept of getting two options. 3 are better, 2 is okay, 1, yeah. So then we go into engineering development. We haven't purchased anything, we haven't spec'd anything at this point. But the goal here is to develop and validate technical solutions and validate against the concept requirements of performance, reliability, maintainability, 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 safety, I guess I should say that one a lot too, but, and economic feasibility. And the concept here is, hopefully you're seeing, we're going back and we're looking at the concept. We're looking at the engineering process, we're looking at what's being proposed, and we're going back and saying, does this satisfy the original concept? Does this satisfy the original need? Am I solving the original problem by putting this in? Am I doing a whole bunch of extra stuff? Or am I getting the job done? And then we get to execution and operation. And when you've developed it and you've purchased it, at some point you've got to assemble it, you've got to test it, and you've got to sign it off and pay the bill. And one of the biggest fears in my personal career is that moment in time when everything comes in and they start assembling it and somebody goes in your office and goes, nah, it doesn't fit. Has that ever happened, or am I the only one? People kind of shaking their heads. Nobody's putting their hand up for that one. Oh, yeah, it's me all the time. But that's the fear. The fear is we have to do it again. We have to go back through the process. And what I'm proposing to you is the scope, if done right and developed properly, eliminates the need to go back and do the project over again or go in and do the supplemental. Does it happen? Yes. Do we miss details? Yes. But by and large, if we've done the iterative process and we've confirmed and we've gone through that development process and tied what we're buying against what's our scope, it fits. It builds up. We sign it off, we pay the bill, we go to the next project. There's a process within each of those stages, and this is a little bit of the iterative part. We start with we have a requirements analysis. We look at the objectives. We're putting into that the objectives. What is my need? What do I have to do? Out of that requirements analysis, we develop, these are the requirements. This is what it looks like physically, mechanically, electrically. These are the interfaces. This is what this beast looks like, whatever the beast is that we're creating. And from that, we get functions. Hey, I want to build storage. I need to put product in, I need to take product out. I need to put in this much, I need to take this much out at this rate. From that, we start to build the physical definition. Well, then your storage needs to be this size. Your conveyor needs to move this quick. You need to have this large of a piece of equipment. And from that, we build a model. It could be on paper, it could be however. And we basically have designed a solution. We then take that back and compare it against the requirements, because it is really cheap to fix it here. It is really not cheap to fix it when the conveyor's in and you're moving product and you're going, nah, we're a little light here. This needs to get bigger. So the three basic stages of the project process, the stages are sequential. If you're skipping the stages, if you're going right to, hey, call up your local whomever, I just want you to deliver this. We know what we're doing. If you're skipping the stages, that's not a good thing. And the results of each one directly ties to the quality of the next stage. And inside that, the process is iterative. We go around that circle. We compare back against the requirements, ultimately forcing the fact that the completeness of your scope, that once the need is defined, and you've defined a very complete scope, it's the first step, but it's ultimately the fundamental step here. Now, what we haven't talked about is, we had the opportunity as a part of this developing our presentations. Bill and I both received a whole series of, questions and answers with some industry players, and both consultants and suppliers and manufacturers and builders. It was pretty good stuff. And what I found interesting was in each of those, they talk about three things. They talk about it in different terms, and I'm going to give you a term here. If you've never heard it before, you should just start throwing it around because it's a great term. It's the triple constraint. Every single project you will ever deal with is constrained by these three legs of the stool: money, quality, and time. If you change any of those, you change the other two. Hey, I need to put in storage. When do you need to have it done by? Next week. Good luck. Well, you can do it. You're going to pay more, and you might chip down on the quality. Hey, I need to put in a top-end conveyance system. Okay. How top-end? I mean really top-end. Okay. It might take a little longer. You're probably going to pay more for it. And in that, there's the balance. And if you recognize that those are the three things that you're continually balancing, all the discussions that happen internally, and not that there's ever conflict between the operations guys and the engineers. That never happens. And the maintenance guys, we get along with everybody, because that's just the nature of our jobs. But when we start talking in these terms, and we're defining scope in these terms, it makes the conversations a lot more honest. Because the communication, how we communicate and what we communicate, ultimately against the reality, greatly affects how we complete those. And why is, as part of this, we talk about communication. Everybody knows, we need to communicate better. So the other thing I didn't tell you about this presentation is it's interactive. So I'm not going to ask any specific person a question, but I want everybody to look at their neighbor, the guy sitting next to them, or anything. I want you to look at the screen, and then I'm going to ask two questions. And just be honest. And the first question is this. When you look at this screen, I want you to think, what is the first thing that I see? And then I'm going to ask a question. And I just want an honest answer. I've done this with a number of groups. It's always worked. I hope it works today. Otherwise, if it doesn't, you guys are all geniuses, and I'll never do this again. So what is the first thing that you see when I pop this up on the screen? Don't say anything, just think it in your head. Okay. Who sees two people leaning against a wall? Does anybody see that? Put your hand up. All right. Who sees a face? Who doesn't see anything? Just out of curiosity. All right. I want you to think about that the next time you're having a conversation within your company and somebody says, I want to put in a big conveyor. I want to put in, and I have to laugh, because, and I'm sorry, and I know we're videotaping this. I work with Greg every day, just about every day. And he and I have this debate, and it doesn't happen all the time, but it's this. And so anyway, he's sitting here looking at me, he's giving me a very smug look, so I think it's funny. But I have the mic. I want to put in a big conveyor. I want to put in big storage. We just need to expand. Well, how much? I need to put in ground storage. How much? When we don't define that, all I did was put a picture up. In a room of 200 people couldn't agree. People saw different things. We're going to see different things from the people that we work with. We need to be willing to have those honest conversations. And as we use the tools, we need to keep that in mind, that these are the tools that are available to us. And as we use these, we need to keep in mind the fact that people don't always see the same thing, even though they're looking at the same document. So the key fundamentals, I mean, there's a lot of software packages. I'm sure most of your companies have an engineering design package, and it takes you all the way through the process, magically kicks out an excellent result. But sometimes you need more than that. So there's some key fundamentals that we need to apply every time we start talking about project scope. The first one is the deficiency and the goal solution. We then have interface management and a feasibility study. These three stages, these three fundamental pieces of the puzzle, if you haven't gone through all three and you're proposing a project, I would highly suggest that you go back and pick up the slack where you might have missed something. If you're an executive and you're asked to approve a project and they haven't gone through a deficiency and a goal solution and we haven't looked at that, they haven't properly defined interface management, hey, how's this thing going to tie into the plant? If they haven't done a solid feasibility study, it's your money, but I would recommend maybe go back to the drawing board. So let's talk about deficiencies and goal solutions. Write it down. Simple, clear statements. When I was at Johns Hopkins, and I thought this was kind of funny, but we used to use wills and shalls. And I thought that really sounded goofy until I started doing it. When you write a statement on a piece of paper and you say, this conveyor will move 50,000 bushels an hour of soybeans, it's pretty definitive. I'd like to move about 50,000 bushels an hour of soybeans. It's not very definitive. You're not necessarily going to get what you want, and because about 50,000 to this gentleman might be, about 50,000 might be a totally different result to the gentleman sitting over there. Write it down, simple, clear, bullet point statements. And if you have a whole page of it, and we're going to talk about this a little bit more on a project that I worked on, but take the 30,000-foot view and say, this is what I really want it to look like, and bang, 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 bang. Simple, clear, and use the triple constraint. Talk about total money. There's nothing wrong with saying our company's standard for investment needs to be whatever that return is. Call it out early, because it sets everybody in motion that, hey, from a dollar's perspective, I've either got to hit this or I'm not going to hit it. and if I don't hit it, we're not going there. Talk about quality. What result do you want? You know, we talked about, Bill had mentioned before, if you have certain standards that you utilize or suppliers that you like, call them out. I would even go to the point of in a different industry, we had certain bearing suppliers. Hopefully there's no bearing suppliers here who are going to be offended by this, and I'm not going to say names. But we had certain bearing suppliers that we did not use, and we called them out in the specs. XYZ, which is nice because they're all three-letter names. Anyway, XYZ, no equal. Or you will not use XYZ. Call it out. What quality are you looking for? Timing. When do you need to get it started? Again, I go back to the wills and shalls. This system will be operational on September 15th. Or this operation will be running in the middle of September. Who thinks the middle of September is the 10th? Somewhere in the middle. And who thinks it's on the 20th? We were challenged last year within our organization. We needed to supply a conveyor. We had an incident. We needed to replace a conveyor, a fairly large conveyor. People in this room were probably involved in that, some of the suppliers. And as a function of that, we sat down and we said, when does this thing need to come up? And we put a date on the table, and it was a date. And we put a conveyor in 200 foot in the air. And we did it, but we didn't do it because we went, middle of September, September 15th, it will be running. It's all about communication. Everybody need a little retraining class on communication? Focus on the board. Who sees a man? Who sees a woman sitting there? Who really is not paying attention? Let's talk about interface management, my personal favorite of all these topics. We're going to define physical, mechanical, electrical interfaces between the subsystems. If we don't do that, if we get too far down the path and that hasn't happened, bad things are going to happen in that you're going to put a system in and it's not going to be ready to run. I'll give you an example. We designed we'll just go with a system. We designed a system that required air. No big deal. We said, well, we have plant air. We designed the whole system, put it in, installed it. Turns out, plant air stopped 1,000 feet away. Multiple buildings and a railroad track were between us. Makes it tough to go and run it on plant air. You work it out, but it's an adder. It's something that we had not anticipated having to do. We had not sat down and laid out what are the interfaces of this system. Define the boundaries. Where can your system operate? Where can it not operate? What can it affect? What can it not affect? From a safety perspective, can I do hot work? Hot work, combustible dust. We talked about it all morning. One of the things that we are working on in our organization is to establish a standard that says, in all cases, unless specifically identified, we want work done, we want systems installed with no hot work. Quote a job with no hot work and see what your contractors do. They look at you like you're crazy, but you define the boundaries. Again, it's defining a boundary as we go back to, and there's reasons for that in our organization that we've chosen to focus on that. But as we do that, we come back and we find the exceptions and we say, well, hey, we can't get around it in this particular case. Then we have to go back and look at what is the need, what is the deficiency, can we work around that? But define those boundaries up front, because it will save you heartache in the end, because when you go to install your system and you're running grain and you realize I can't strike a torch because I've got active conveyors and I've got a potential for dust, that's a problem. Let's talk about feasibility studies. We all love them. Everybody here's been involved in many of them. What's the goal? I love 2 screens, by the way, and I have a third one up there. I don't know where to look. At every stage, we're testing the concept or concepts against the goals stated. So most people think feasibility study and they think, can I financially do this? Can I pay to get this project done? It's beyond that. It goes more than that. It's not just can I get the project done for the money that I have allocated, but it's also will the project accomplish the goal that I want it to accomplish? If it doesn't get the job done, we shouldn't be spending any money on it, and we need to go do something else. Include outsiders in your analysis. I love when we sit down, and I'm sure that my particular organization is no different from the others, but we sit down, we have a meeting, we're going to talk about a plan, we're going to talk about a project, and you look around the room, it's like 3 maintenance guys, 4 engineers, and me. Now, clearly, maintenance is well represented, and the maintenance guys would never make a bad decision, and we would never design a system working with the engineers that wouldn't be perfect for those in operations, because I know this would never happen. No one is even chuckling. That is hurtful. Clearly a whole room full of operators. But we have to bring in a well-rounded group. You have to put together a group that's going to analyze this and have honest conversation. Financial people, operators, maintenance guys, engineers, whomever. You need safety people. I mean, we have to get that team, and I encourage you and your departments and your teams to be willing to put those together. Why invite others to the party? One of my favorite slides used to hang in my office. You know, now a side note here, where I got my master's at Johns Hopkins, it was what they call Inside the Beltway in DC. It was a whole bunch of DoD, Department of Defense, contractors and developers and designers, and these guys worked on missile projects and all kinds of everything else. So everything that we worked on, every class project had to do with a missile. So I offer you that. But anyway, the ideal missile design from the viewpoints of various specialists, and you start looking, and the aerodynamic guy wants a perfectly aerodynamic system. The guy who wants to talk about structure has got one made out of beams. It's not going to work. It's never going to fly. But the point is, everybody views the perfect system differently, and ultimately you have to pull that whole group into the room and have some honest conversation. Be focused on the end, be honest, and be well written. These promote success as we go through some of those tools, because it's about communication, right? It's about talking to your colleagues. It's about talking to your contractors. What are we trying to do when we do that? Well, my goal, and I use this expression often, is corporate amnesia. We want to avoid corporate amnesia. So we've all said, now I get chuckles. There we go. We've all sat in a room and we go, hey, why did we do that? And everybody looks around and goes, nah, I don't know. You go, well, what do you mean you don't know? Well, I think I remember this conversation. I remember that one. And nobody knows. The goal is to avoid amnesia. I've had it once or twice. How do we do that? The best principles to promote success. And success in my world in this concept is avoiding the ability to go, I really have no idea how we got here. Because that happens. We have projects, and everybody's been worked on one of them. I would assume most people have worked on one of them, where somebody goes, I have absolutely no idea why we picked that. And you go, well, be honest with each other. When you're doing a feasibility study and it's just not going to work, let's be honest. Let's say it's not going to work. We need to walk away from it, or we need to reassess this. It is better to have your great idea put in a circular file than in a whole series of dumpsters that you have to line up because you installed it and it didn't work and now we got to do it again. Be well written. Define your assumptions, write them down. This is about the wills and the shalls and the expanding of those concepts. If you write them down, you can flip back to them and later and go, That's why we did this. That was why this was important at the time. And continually be focused on the end. As you develop your scope, your requirements tie back to your scope. You define the details. You question your details against the requirements, ultimately questioning it against the scope. Take a minute and utilize that document that you're creating because you're now well written and define the testing standards. What is the part that I'm going to say is pass or fail on the project? And be honest. Again, this is about conversation. A part of it is about communication. Communicate with your contractors. Hey, these are the standards which we are going to test this against. If it doesn't pass, you've got to fix it. We've got to get there. And if we're honest up front, it also keeps from that slipping of the scope, that creeping of the scope, where suddenly things are getting bigger and faster and they don't need to be. So let's talk about application. As was mentioned before, I had the opportunity to spend 2 years in China. It was a great opportunity. You can ask my wife if it was a great opportunity. She may give you a slightly different answer. But while we were there, when I went to a former company, they were building a greenfield site in China. I was asked to go over. Hey, Bill, can you go over? Look, we need you to go over like maybe 2 trips. Just 2 trips. We need you to commission some equipment, help us with the commissioning. Two trips. No problem. 2 years later, I'm commissioning a whole new section of the project that we had decided we needed. And in that process, I got to utilize this in a very big way. And the opportunity to develop a project when you don't speak the language of the local people, it becomes real important that your communication is very well defined. So the top level scope definition, that I was given was we need to install equipment to make a specific product. We need it running to support this defined market. We need to hit and achieve at least a minimum return on investment. And, oh, by the way, we need it running in 2 years. Wait a minute. Hang on. Let's go back. 2 years. Are you serious? Yep, we're serious. Okay. So off we went. We start talking about the triple constraint. We had defined the time. There was non-negotiable time limits. We had said because of the product that we were making, we had defined the quality that we required for the process. To complicate matters, the company I worked for at that point was a conglomeration of European and American companies that had come together. We didn't always agree. So we spent a lot of time defining what is this beast going to look like that we were going to make. But once we got there, we defined the quality, we had the time. It's all about the money at that point because you've got to make the balance. We built a scope definition that was 360 discrete lines. The best part was it is interpreted completely to Chinese as well as English. We relied on an excellent interpreter to do that. But the first series of lines in that scope that we continued to hammer out and continued to refine were the guarantees. We need to make this much product. We need to only use this much energy. We need to have availability of X percent. We defined them, we called them out early in the process, and we continued to refine them and go down that road. And as we did that, it was amazing how having this document sitting on the table in every single meeting that we had, it made things run a whole lot smoother. Because there's not a lot of questions when you've got 334 lines of documentation and you go, well, this is what we want, this is what we told you we wanted, this is what we needed to create. We tied to that acceptance testing. Now, what industry I worked in the refractory industry. What all of this is really irrelevant, but we had called out, part of this, what we built was an industrial oven. It was 300 feet long, it was 12 foot tall, 10 feet wide conversationally, had a rolling rack system. Key thing to this working is the racks. If the racks fall apart, you've got a problem. If the racks aren't even, what we're making isn't going to work and it's going to crack through the curing process. We spent a lot of time defining, and we had these operating elsewhere in the world, we spent a lot of time defining, here's the drawing, this is what we need. At 250 racks manufactured, I go over to sign off sign off that we're going to accept these things, and I asked the guy, I said, well, I need a straight edge. He goes, why do you need a straight edge? I said, because line 3.12.2 says these racks need to be built to this standard. I laid out the document. I said, and I'm going to test X quantity of these to that document. Well, what do you mean? Oh, I mean, I'm not signing off your racks until I get to test these. It's not new. It wasn't a shock. He knew. Everybody knew. This is the standard. We had established it. 5 trips later, we signed off those racks. But the key thing is, it's not the horror story, because we've all got the horror story. Had we not defined it early in the process, we're in a world of hurt. We're trying to run a system, and we don't have racks to run the system on. Other things that we got into, and this is where, and the comment, Bill made the comment, I thought it was great, the devil's in the details, one of my favorite sayings. One of the other things that we had defined was we had defined how is this thing going to rest on the foundation? How are we going to install this? What you may or may not be able to see is in this support, I have got some flat plate, got some key stock, I've got a piece of bar that they took from I don't know where, I've got some threaded rod, and I've got some grout all kind of hodgepodged in there. That wasn't the spec. We changed it. But we couldn't have changed it had we not defined it. We wouldn't have defined it had we not defined the full scope of this is what we want. This is the quality of the system that we want to operate. So back to basics. Why do we need to have this conversation today? What's the value of this? So going back, we talked about very early on, the first thing I talked about was 0.013% of people that play Little League have a chance to play 1 inning in baseball. So here we have an actual baseball player. I think a 19-year career, National League batting title, 5 top 25 MVP years of votes, 2,700 hits, 1,200 RBIs. And everybody in this room goes, wow, that's not bad. I mean, he's not, but that's not bad. But the point is, all of that gets forgotten, and every project that you work on, every good one you do, every hit you get, every National League batting title, or the conversation of what that would be in your industry, gets forgotten. If you forget to put your glove down in the 1986 World Series on a Mookie Wilson hit down the first base line and the run scores. And my point is this, we have to go back to basics. Every time we do a project, we need to drive home those key points. We need to sit down as a group. You need to sit down in your organization as a group and have that conversation, have those real world, this is what we need, this is what the scope needs to look like. Define it, write it down, follow the process. It doesn't 100% guarantee success, but it's going to help you in your project development. And I think we have questions from, I don't know how we're doing the questions, so I'm going to go sit down now because people are coming up to chase me back to my seat.